In this video, we will continue to investigate constant percentage change situations. We will do so by considering what happens to the output values of the functions when the input values increase by 1. Question 1 asks you to consider the doubling function. As the input value, x, increases by 1, how does the output value change? For example, when x increases from 3 to 4, f of x increases from 8 to 16, because 2 to the third power is 8 and 2 to the fourth power is 16. Describe the relationship between these two outputs. Does your description hold if we let the input x change from 5 to 6? Remember, we are thinking about 1 unit increases in the input value x. Answer parts A and B as you think about these things here. When you get to part C, evaluate values of x to see what happens when you let input values increase by 3. If your first value for x is 2, what would your second input value for x be if it had increased by 3? How would the output values of the function compare when the input increases by 3? Think about these questions and provide your answer, and then move on to part D. Question 2 asks you to consider the graph of the doubling function. Recognizing the fact that the graph represents all possible pairs of input and output values for the function, answer parts A, B, and C for question 2 while reasoning with the graph. This question asks you to reason about how the output values change as the input values either increase or decrease. Use this opportunity to strengthen your ability to think about how two different quantities change together. Don't forget, part C is on the next page. Question 3 asks you to consider an animated illustration of how the quantities in the doubling function change together. In this animation, the input variable x equals a. The a values are allowed to vary, to increase. The size of the blue vertical line segment above x equals a represents the value of the output quantity for each input value of a. As the input values vary, the animation also shows the size of the output for each input value that is 1 more than a, or a plus 1. Compare the relative sizes of these two output values for every possible value of a and a plus 1 as you watch this animation. Answer question 3 and express the big idea or ideas demonstrated in this animation. Feel free to pause or restart this video so that you can see what's happening in the animation. Submit your answers to all parts of questions 1 through 3 in Module 4, Investigation 3, using your instructor's preferred method by the time and date that your instructor has identified.